Good afternoon, everybody. I'm Timothy, and in today's video, we are going to be doing sequence and word series. What do I hope you understand at the end of this video is just a clear definition of what a sequence is and also what a series means. And without wasting much of our time, I'll just go straight to defining what a sequence is. What is a sequence? The sequence of a number. Let's say the number we are talking about is A1, A2, A3 down till the last number you want to work with. I will say that the last number I want to work with is what? A subscript C. Why am I using C? I'm using C because C starts my name, Chukwebuka, and I love my name so much. So that's why I use C. So that number is just what this a sequence is the collection of all the numbers that you want to work with, written in what? In an orderly pattern. Arranging them and writing them in an orderly pattern is the most important aspect of what? Of sequence. Without writing them in an orderly pattern, it is not a sequence. Let's take example. Let's take for instance that A1 is equal to 3, A2 is equal to 4, A3 is equal to 7, A4 is equal to 6, A5 is equal to 5. So now, and you want to write this number in what? You want to sequentially write this number. So what you are going to do now, you are not going to write it A1, A2, A3, A4, A5. No. Because this A1, A2 is what? 3, 4, 7, 6, 5. This is just a number that you wrote. It is not written in sequence. It is not written sequentially. So what you are going to do now is the values, you write them over 3, 4, 5, 6, 7, which is going to give you A1, A2, A5, A6, A7. And that leads me to define a sequence as the collection of the values of the number you want, of the collection of the values of what? These dummies. When you collect all the values of these dummies, substitute them and what? Arrange the numbers in what? In order. If you want to arrange them in order of ascension or order of descending, it doesn't matter, but all that is needed for you to do is arranging them in orderly pattern, orderly form. So, and remember, this is just example. So now, that will now carry me to this question I want to ask you. Does a sequence always follow a particular pattern of forming numbers? When I say follow a particular pattern or a, let's take them, the normal counting numbers, the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till infinity. Now, the normal way of counting this number is 1, 2, 3. Now, I want to ask, since a sequence is the collection of all the numbers you want to work with, arranging them in what? In order of precedence, in order of maybe ascension of descent or descending. I want to ask this question: does a sequence always follow a particular pattern of forming numbers? Well, the answer to that question is no. The answer to the question is what? No. Don't worry, don't rush. I'm going to show you the one I know. So now we have done the one of natural numbers. Let us also see the one of even numbers. Let's take even numbers. You know, even numbers. Okay. The general method of writing these natural counting numbers is n plus 1. Remember, if n equal to, okay, n greater or equal to 0. If n is equal to 0, we'll have that what? A1, A is equal to, we'll have that. If n is equal to 0, we'll have 1. If n is equal to 1, we'll have what? 2. If n is equal to 2, we'll have what? 3. So on and so forth. If n is equal to 3, you have 4. If n is equal to 4, you have 5. blah 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 blah. So that is the natural, that is the normal way of what, that's the way we form this natural counting numbers. So we go to even numbers. We have 2, 4, 6, 8, 10, 12, 14, 16, 18 till infinity. So now the normal way, the general pattern you can use to form this even numbers is n plus 2 or 2n, n greater or equal to 0. If we use n greater or equal to 0, this one is not going to work. We use this one. If we use n greater or equal to 1, then this one includes. They say, so now let's use this one, n greater or equal to 0. If n equal to 0, we have 2. N equal to, you see something, n equal to 1, you have 3. You have 3. N equal to 2, you have what? 4. So this is not going to work. We have that it is what? 2n. We have is what? 2n for n greater or equal to 1. Meaning n, if n equal to 1, we have 2. N equal to 2, we have what? 4. N equal to 3, we have what? 6. And that is it here. So that is what the normal pattern of writing these even numbers. So let's go over to odd numbers. We have what? 1, 3, 5, 7, 9, 11, 13, blah blah blah. And the normal way of writing this is what? 2n plus 1 or 2n minus 1. N greater or equal to 0. If we use n greater or equal to 0, if we put it here, we have what? 2, 0 plus 1 to give us 1. Put it here, we have what? 2, 0 to give us plus minus 1 to give us minus 1. So if we are using n greater or equal to 0, we don't use this. But if we are using n greater or equal to 1, see 2 minus 1 will give us 1. So if we are using n greater or equal to 1, this is included. If we are using n greater or equal to 0, we use this. But if we are using greater or equal to 1, we can use the both of them. So now, remember, we have in numbers like this, we have even, we have odd. And in this odd, there is what I call odd and I call what? Prime. I call this one odd just because I don't know the other name to call it, so I call it odd. Here I call it odd numbers, and here I call it odd prime numbers, or prime odd numbers, odd what numbers, and here is even numbers. Now you might be saying I'm deviating from what I'm saying. No, I'm not deviating. I just want to show you that it is not always true that a sequence of a number follows a particular pattern of writing numbers. So let's see prime numbers. We have what? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. So now, if you check here, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, this minus this 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 is 2, this minus 2 minus 1 is 1, 3 minus 2. So they have what? Many words. They have all this one have a unique way of what? Forming their numbers. But let's check this one. 3 minus 2 is 1, 5 minus 3 is 2, 7 minus 5 is 2, 11 minus this is 4, this minus this is 2, this minus this is 4, this minus this is 2, this minus this is 4, this minus this is what? 6, 2, and what? 6. So you see now, there is no pattern, there is nothing you can do to arrive at a general formula of writing what, of forming a prime numbers. So now what do we actually arrive at? We arrive at, it is not always true that sequences must have what, a particular way of forming numbers. That is that. And that will now lead me to if statement. Now, one of my conscience, let me just be using myself. I don't want to call somebody's name before I get arrested. So one of my conscience now says, what if we work only with numbers that have a general method of writing or forming what if we work with numbers that have general method of forming the numbers? For example, we have the even numbers, which is n, which is 2n, which is 2 what? 2n. What if we have something like that? Or let me say, what if we have a number, let us say number n plus 2? Now this is the formula we want to work with. So if n equal to 0, we have what? 2. If n equal to 1, we have what? 3. If n equal to 2, we have what? 4. If n equal to 0, we have what? 2. If n equal to 1, we have what? 4. If n equal to 2, we have what? 8. If n equal to 2, equal to 3, we have what? 2 times 3 is 6 plus 2. 2 times 3 is 6 plus 2, 8. Times 2 is 4. Okay, we have 6 here. Here we have what? 8. So now we see we have what? Even number 2, 4, 6, 8, 10, blah. So that my question now says, what if we work with the ones that have what? A general pattern of forming the numbers? What are we going to get? Now, my sense and my brain now says, if we have a sequence of numbers, say A1 as the first term, A2 as the second, A3 as the third, till A last as the last term, A last as the what? As the last term. And you form the second, and there exists what is called a common difference, that when you do A1 plus A2, you get what? Sorry, A1 plus the constant, it will give you what? A2. You now do A2 plus constant, you give you what? A3. When you do this now, know that that sequence that you are in is what they call arithmetic what? Progression. Arithmetic what? Progression. Let me explain it again. Now, if there exists a sequence of numbers such that A1 is the first term and A2, A3 till A last are all in that what? Terms, are all the terms in that numbers, and you form the second one by adding a constant. What I mean by a constant is this form, in this value now, in this general formula now, this is a constant and this is also what? A constant. The only variable there is what? N. So for example, we have what? We are dealing with n plus 2. N equal to even numbers only. So now, if n is equal to 2, A is what? 4. A1 is equal to 4. If n is equal to 4, A2 is equal to what? 6. So on and so forth. This is yes. So now, That is what I'm saying. If you are in this kind of progression or in this kind of sequence, know that we are dealing with what? Arithmetic what? Progression or linear sequence. Linear what? Sequence. So that is it. And also, another mind said, what if you don't add? Because in arithmetic progression, A1, A is what? The first term. A1 plus D is the second term. A1 plus 2D is the third one. A1 plus 3D is the fourth one. A1 plus 4D is the fifth one. Down till A1 plus N minus 1D is the N term. So now, this is it. So Anderman said, what if you don't add these differences? What if you don't add them? What if you multiply them? And I said, wait, what you are saying is, instead of saying if, what they say is if A1 is equal to 3 and the difference is equal to 4, instead of A2 to be equal to 3 plus 4, it is now going to be what? 3 times 4. Instead of A2 to be equal to 7, it will now be equal to what? 12. And now ask, is this what you're saying? You say yes. So okay. And now we'll start what? Researching, and I say that this is called what? Geometric what? Progression or exponential sequence. Geometric progression or exponential sequence. Geometric progression or exponential sequence is the sequence of numbers with A1 as the first term, and the second term is formed by multiplying the first term with the common what? Difference. Normally it's called the ratio or factor. When you multiply the first term with that common factor, you get the second term. Or when you multiply the second term with a common factor, you get the third term. Or if you divide the first term, if you arrange in descending order, if you divide the first term with the common ratio, you have what? The second term, so on and so forth. So the only difference in geometric progression and arithmetic progression is that in arithmetic progression, you add the common difference to the first number, to the first term to get the second term, and you add it to the second term to get the third term. And in geometric progression, you multiply the first term with the common factor to get what? The second term, multiply with the second term again to get the third term. So that is the only difference between arithmetic progression and geometric what? Progression. And also, another mind said, what if you are working with inverse of arithmetic progression? I say, instead of saying A1 equal to, instead of saying A1 equal to the first term, I'll now say 1 over A1. The mind said yes. And instead of saying A1 plus D, I will now say 1 over A1 plus D, second term. Yes. I now went to research and I found out that this is called what? Harmonic progression. Harmonic what? Progression. So I'll just do a recap of everything I've said. It is not always true that a sequence follows a particular number while forming a sequence. And the sequence of a number is the collection of all the numbers you need, arrange them and put them in what? In orderly pattern. It might be in descending or ascending order. And we also have what? Progressions, arithmetic progression or the linear progression, the geometric progression or the exponential progression, and the harmonic what? Progression. And how you know that you are working with a progression, arithmetic progression, is when the common difference is being added to the first term to get the second term, or you add it to the second term to get the third term, or you subtract it from this third term to get the second term, or subtract from the second term to get the first term. That is when it is arranged in ascending order. If it is arranged in descending order, you subtract the common difference from the first term to get the second term, subtract it from the second term to get the third term, add it to the third term to get back the second term, add it to the second term again to get back the first term. That is what arithmetic word progression. Normally, all you need to know is in arithmetic progression, it is what addition and subtraction. But when you come over to geometric progression, it is ratio and what factor. When you get the common factor, you multiply with the first term to get the second term, multiply with the second term again to get the third term. That is when it is arranged in what order of ascension. But if it is arranged in descending order, you divide with the first term to get the second term, divide with what the second term to get the third term. That is when it is arranged in what descending order. So when it comes to harmonic progression, it is just only the reciprocal of what of arithmetic progression. So that is where I'm going to stop today, and I hope you understood my explanation. You might say I did not explain series again. Don't worry, that will come in the next video, but let me just give you a hint of what series is. It's just addition of all what the sequence in your set of numbers. Thank you. I remain Mr. Chukwuebuka Timothy. Do well to like, subscribe, and share. If you have any question to ask, you can put them in the comments box below. When I see them, I attend to them. Thank you once again. Have a nice day.